All right, so 5.1 deals with rational expressions. And then when we do 8.5, it actually deals with rational functions. So pretty much the same top subject. So the first couple examples in 5.1, they want you to find all numbers for which the rational expression is not defined. And you know, when you see rational expression in math, a rational expression is basically a fraction, okay? So now they don't want me to find a domain. They just want me to find any numbers that'll make it undefined. So they're giving us 6c squared minus 10 over 9c plus 25. So if I'm going to find numbers which this is not defined, that means I cannot have a 0 in the bottom of this fraction. So remember, the bottom of this fraction cannot equal 0. So what we do to find numbers that do make it equal 0, same thing as finding domain. I'm going to take the bottom of my fraction, 9c plus 25. And I'm actually going to set it equal to 0 and then solve it for the c. Once I solve this for the c, that'll give me the numbers that I gotta include that'll make it undefined, okay? So to solve this, we're going to subtract 25 from both sides. So I get my 9c, that cancels, and that's going to give me negative 25. And then divide both sides by 9. So that cancels, giving us our 1c. And y'all, we can't do nothing with that, so we're going to keep that a negative 25 over 9. So the answer blanks will say the rational expression is not defined for c equals blank. And y'all, all we're putting in that blank is that number we got, which was what? A negative 25 over 9. And what they're doing, they're just getting us ready for the domain stuff again. So for number 2, the same thing. But this time they got a z squared minus z minus 5 all over z squared minus 16z plus 63. So the difference on this one and the first one only had a c as my variable, but y'all down here, I got a z squared. So I'm still going to take the bottom of this, z squared minus 16z plus 63, and I'm going to set it equal to 0. And y'all, on these, when we got a z squared, the way we got to solve that is by factoring on this one. So the z squared means you got a z in the front of both parentheses. So y'all watch this. I'm going to put my signs in here. Remember, the last number is positive. If the last number is positive, then both of these factors will have the same sign as the middle number. So since that 16 in the middle is negative, both of these factors will be negative like the middle. And y'all, that's all because that last sign's positive. So now, to finish this out, I need to find factors of 63 that add to get 16. So 63 could be 1 and 63. It could be 3 and 21. Oh, let's see, what else can I do? I can do 7 times 9. And y'all, that's all the ways I can multiply to get a 63. So the one of these factors that adds to get me a negative 16 will be the 7 and the 9. So I come in and put my 7 and 9. Now, to finish this off, I got to set both of these equal to 0. So I got my z minus 7 will equal 0. My z minus 9 will equal 0. So solve both of these by adding 7 to the first one. And then add 9 to the second. So on this problem, the rational expression is not defined for z equals blank. And y'all, since I had two numbers, I would have to come in and put my 7, 9. So the first two problems, they don't want the domain, they just want the numbers that you would technically exclude from that domain. Now, starting at number 3, they're going to want the actual domains. And on the domains, they're going to write them in set builder notation and interval notation. And we've been doing domains, so this is not too new, except that they're putting x squared terms down there. So for each function, and these are rational functions, write the domain. In set builder notation and interval notation. And I think they got about 3 or 4 of these that we're going to do. So starting at number 3, they're giving us f of x equals 6x minus 7 over x plus 2. So y'all, like I said, we'll solve this. I'm going to write it in both set builder notation and I'll write it in interval notation. So to find the domain, once again, the bottom of this fraction cannot equal 0. So what we got to do is set the bottom equal to 0 so that we can find any numbers that'll make that happen. And y'all, we just got one move on this one. X plus 2 equals 0. We're just going to minus 2 from both sides. And we get an x equals negative 2. So for set builder notation, they'll have this part, x such that x is a real number. And x cannot equal blank. All we're putting in the blank is the number we got, negative 2. Okay, so all you got to do is put the number on that one. Now remember, I'm going to do interval notation, so I got to exclude that negative 2 from my domain. So remember, interval notation, we start at negative infinity, and we're cruising along the x-axis until we hit negative 2. So we're going to kick negative 2 out by doing a union around that negative 2. And then there's no more numbers to kick out, so my domain will go all the way towards positive infinity. So every one of your answers is going to start at negative infinity, and it's going to end at positive infinity when you're doing interval notation. You just got to union around any numbers that we're kicking out. All right, so same thing on number 4. They got g of x equals 5 over 2x minus x squared. All right, so once again, we're going to set the bottom equal to 0. 2x minus x squared equals 0. So y'all, to solve this one, it's out of order, but it's not bad because you got a 2x and an x. So on this one, instead of actually factoring the whole thing, what I'm going to do on this one, I'm going to factor out the greatest common factor of x. Since these two terms have an x in them, we're going to factor out that x. In parentheses, if you have a 2x and you take out the x, you're left with a 2 minus. If you had an x squared and you take out an x, you're left with an x. So now we've got it factored by factoring out to GCF. So now set both these equal to 0. So we'll have x equals 0, and then 2 minus x equals 0. So the first one's already solved. I can't do nothing to that. So one number I'm going to exclude will be 0. On the second one, y'all, to solve this, all I got to do is add an x to both sides. And this one gives me 2, because that cancels, equals my x. So x is 0 and x is 2. So those are the two numbers I got to kick out. So for the first set builder would be x such that x is a real number and x cannot equal a 0, 2. Now, usually in these, you got to put these numbers in order that they would go from left to right on a number line, okay? Now, my domain starts at negative infinity. First number I hit would be 0, so I'm going to union around that 0. From 0, we would go until we hit 2. So now we got a union around that 2 to kick it out. But y'all, from 2, there's no more restrictions. So I'm going to go all the way to positive infinity. So notice 2 numbers got kicked out, so I had to do the union twice. But it still starts with a negative infinity and it ends with a positive infinity. So y'all, it's not much more than what you did on my second test. All righty, let's see what this one has. 5 has an f of x equals 6x squared minus 77 all over 7x plus 19. See, on the same thing, we're going to set the 7x plus 19 equal to 0. Now this time I don't have any x squared terms. So since I just have an x as my variable, I'm only going to get one number to exclude. So start out by subtracting 19. We'll get our 7x, that cancels. That's going to equal negative 19. Divide both sides by 7. So I get x is a negative 19 over 7. Can't do nothing to simplify that. So one number to kick out. So x such that x is a real number. And x cannot equal the negative 19 over 7. Interval notation, I'm just going to union around that one number. So we're going to start at negative infinity till we hit that negative 19 over 7. We're going to union around it and then go from negative 19 over 7 to positive infinity. So y'all, they're not too bad. Just got to remember to start at negative infinity and end at positive infinity and go left to right on that number line, okay? All righty, one more in this section and then we'll move on. All right, for number 6 in that section, f of x equals, all right, on top, I got an x to the third minus the x squared plus the x plus 4. On bottom, I have an x squared plus 11x plus 28. All right, let me let one in real quick. All righty, so I do have an x squared term this time. So once again, take the bottom, set it equal to 0. Since I have a trinomial, which is quadratic, and I have an x squared term, an x term, and a number, I'm going to have to factor this one. So in front of both parentheses, the x squared is an x and an x. The last number is positive, so both of these factors will have the same sign as the middle number. So that 11 is positive, so both of these will be positive. So now I'm going to look at factors of 28. That'll add to get me 11. So 1 and 28, those add to get me 29. 2 and 14, those add to get me 16. What's next? Oh, there we go. 4 and 7. 4 and 7 add to get 11. So that's going to be my two numbers. So now I'm factored. Now to get my solutions, I set each factor equal to 0. All right, y'all. So the first one I'm going to subtract 4. I get x is a negative 4. Second one, I'm going to subtract 7. And I get x is a negative 7. All right, x such that x is a real number. And x cannot equal. Now you got to get these numbers in the right order from left to right. So the first number would be the negative 7, then the negative 4. And then I don't know if I got room to shut my parentheses. Yeah. So the negative 7 has to go first, then the negative 4. They got to be in order going from left to right. Same thing on interval. Start at negative infinity till the first number we hit would be negative 7. Union around that negative 7 till we hit negative 4. Union around that negative 4 until we hit positive infinity. So in this notation, it's telling me that my domain is all numbers in between negative infinity and infinity, except for that negative 7 and that negative 4. So y'all, that was 5.1. Just 6 problems. First 2 dealing with undefined numbers. The last 4 dealing with the domain, okay? So let's start looking at 8.5. 8.5 deals with rational functions. Now, they start out finding the domain, and on this section, they just want the domain in interval notation. So they want us to determine the domain of the function. So 2 examples of this, and then we'll get into some new terminology for this section. So y'all, number 1 has f of x equals x squared over 10 minus x. All right, so we're finding the domain. So we know now that when we're looking at the domain of a fraction, we're going to take the bottom of that fraction, 10 minus x, and we're going to set that equal to 0. All right, so the quickest way to solve this would be just to add an x to both sides, make it positive. So notice what I get. I get my 10, that cancels on the left side, right side, I get my x. So 10 equals x. So if I put a 10 here, 10 minus 10 is 0. That makes it undefined. So the domain interval notation will be from negative infinity till we hit that 10. We're going to kick the 10 out by doing a union around it. And then from 10, it heads off towards positive infinity. So y'all, 5-1 and 8-5, the starting part of 8-5, these 2 questions are just like 5-1 was. All right, here we go, a bigger one. F of x equals -3 on top over x squared plus 2x minus 24. So I've got a quadratic equation down here, x squared term, x term, and a number. So I'm going to set this equal to 0. Then we're going to set it up for factoring. So the x squared puts an x in front of both of these. Now watch this. This last number is negative. So when the last number is negative, one factor is positive, one factor is negative. Now, I'm going to find factors of 24 over here. And I'm looking for factors of this 24 that'll subtract to get me that middle number 2. All right, so 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6. So remember, the last one's got a minus in front, so I want factors over here that'll subtract and get me 2, and that'll be 6 and 4. The larger of these 2 factors will have the same sign as the middle number. So the 6 will be positive like the middle, and the 4 will be negative. So y'all look at that. 6 minus 4 is 2. 6 times the -4 is -24. So that's how I sort of check real quick on that factoring, okay? Now to finish this off, set both of these equal to 0. So y'all, the first one, I'm going to subtract 6 from both sides. I get x is a -6. The second one, I'll add 4 to both sides and get x is a +4. So interval notation, we're starting at negative infinity. The first number we hit would be -6. So union around that -6. From there, we're cruising until we hit 4. So we're going to union around 4. And y'all, I've got both the restrictions. So from 4, I'm cruising on till I hit towards positive infinity. All righty, so now I will get into our definitions. All right, so let me see. Run on that already. I'm going to flip my paper over. All right, so the first definition of the day, is a vertical asymptote. So a vertical asymptote, y'all, a vertical asymptote is an imaginary dotted line. Even more specifically, is an imaginary dotted vertical line. It's a vertical line, that's why it's called a vertical asymptote, but it's an imaginary dotted vertical line that the graph of the function cannot cross over. So the graph cannot cross over this line. So let me show you an example of what we're talking about. So say I just had a function, f of x equals, how about 5 over x minus 2. Now, the reason it cannot cross over, because watch this. The vertical asymptotes occur where the function is undefined. So I'm going to have this little graph here. So let's play with a graph. And I'm not going to go out real far. I'm going to go 1, 2, 3 that way. I'll go -3 this away. And then I'm just going to go up 3 on the y and then -3 on the y. So that's my x-axis and my y-axis. So let's just say I was going to make me a little table over here. I'm just going to pick me some numbers to plug in and try to see where they'll go, okay? So if I let my x equal, how about 1? So let's see what happens. 1 minus 2 gives me a -1 in the bottom. 5 divided by -1 would make that a -5. So let me come down just a little bit more and make that a -5 on here. So at 1, my graph is right here at -5.
Wait, how'd you get -5?
I'll just plug the 1 into here. So watch this. If I plug 1 in for the x, I'll do the bottom first. 1 minus 2, so that gave me a -1 on the bottom. And then my 5 divided by -1 gave me my -5. Oh, let me put in what's how about, well, I can use a 0. If I put a 0 in the bottom, I got 5 over 0 minus 2, which will give me 5 over a -2. So y'all, if I was going to figure that out, that'd be about, oh, that'd be -2.5. So my -5/2 over here will be -2.5. So if my x is 0, -2.5 will be about right in here. All right. So y'all, what'll happen on this side, this graph is just want to sort of come down like that. But here's 2. Watch what happens when I put a 2 in here. If I put a 2 in here, 2 minus 2 is 0 on the bottom. 5 divided by 0 is undefined. So when x is 2, I can't put a mark on here because it's undefined. So this is where I would draw my imaginary vertical line. That means my graph cannot cross this line at all because it's undefined when X was at 2, okay? So that's what I'm talking about, a vertical asymptote. It occurs where these graphs are undefined. Now, what will happen if I was going to draw this all the way out? This graph would come in from the left side, and it would keep shooting down towards negative infinity. It would never cross this line, though. It'll just keep going down and down and down. And then the right side would come in from probably positive infinity, and it would come down and just probably head off that way. But the thing is, neither side of this will cross this line. This side just shoots straight up towards positive infinity in the y direction. This side's just going to shoot straight down towards negative infinity. It gets really close. These X values can be 1.999999, but they cannot equal 2, because if it equals 2, that's where it's undefined at. So y'all, that's what I'm talking about when I talk about a vertical asymptote. It's an imaginary line, and my graph just cannot cross it, okay? So y'all watch this on the calculator. I'll do that one on the calculator. And I'll tell you what, so I'm gonna go to y equals the graph is. I always use the fractions on these. So to get the fraction, you hit the green alpha button, the y equals, and then enter. And then on top, I had a 5. Then I'm gonna arrow down to the bottom. I had an x minus 2. So x minus 2. So let me show you the table real quick. So I'm going to hit second graph to show you the table. And look down here where the X value is 2. Notice that graph is giving me an error. It's telling me, hey, you just can't plot that Y value because it made it undefined. Now look at the graph. Remember how I said it would go down and up on that? So here we go. See how the left side comes in? It shoots straight down. Now, the calculator won't draw the imaginary dotted line, but y'all, you can tell where it is. And then that right side, it just keeps going up and up and up. And then the right side, we'll talk about those asymptotes in a little bit.
I have an issue.
Okay.
My calculator, I don't know if I've zoomed it in or what, but there's a whole bunch of little dotted lines on the left. And then I can see the line going above the x-axis.
Okay, so do you have an X and Y axis?
No.
So first thing, hit the zoom button.
Okay.
And then arrow down to number 6 for standard and hit enter.
Okie doke. Thank you.
Okay, that fix it? Okay.
Yes, sir.
Was about to go to other options. Okay, so good job. And yeah, it's possible that it was still set from the other day when we redid them windows. Remember, we had one that we redid the windows.
Yes.
Now, here's
So
the
can
thing.
we use our calculator for these?
Oh,
We
yeah.
can just, okay.
Yeah, so that's why we allow y'all to use calculators, is so yeah, y'all get good on that calculator, because that'll help you when y'all hit them science classes and all that fun stuff. Now, to find vertical asymptotes. Now, the thing about vertical asymptotes, when we write the answer, we got to write it as an equation. Like this one that I just did, since that vertical line occurred at the X value of 2, for this vertical asymptote, the imaginary dotted line would actually be X equals 2. So anything with an X value of 2 made that whole line undefined, okay? So just remember, in MATLAB, it wants it in the form of these equations. If you just put a 2 in the blank, it marks them wrong a lot of times, okay? Now, watch this. Sometimes the MATLAB will already have the X equals, and all you would do is come in and put the 2. So you got to look at MATLAB, how do they got the answers? Do they got the X equals for me? Because some of them, they do put the x equals, and then some of them, they make you do the whole thing, okay? But y'all, here's the thing. If vertical asymptotes are occurring where my graphs are undefined, then we're going to find them the same way we found those domains before. Because the domains, remember, were all values except for the values that made it undefined. So to find vertical asymptotes, I'm going to set the denominator equal to 0. So the first thing we'll do is set the denominator equal to 0 and solve for the variable. The vertical asymptotes will occur at all of the solutions we get. Which means if I got two values I'm excluding, I'm going to have two vertical asymptotes on my graph, okay? And then remember the last thing, right? In the form of an equation. That'll be x equals some number. So to find vertical asymptotes, I'm going to do the same thing I did when I was finding my domains. Okay, I'm going to take the bottom, set it equal to 0, and see what we get. All righty, so these will say find the vertical asymptote of each function. So y'all, let me see what I'm on. I'm on my number. Looks like my number 3. So 3, they're giving me f of x equals 1 divided by x minus 2 squared. So we're going to take the bottom, set it equal to 0. Y'all remember, x minus 2 squared means the x minus 2 times the x minus 2. But remember, these are just repeating factors. Because remember, 2 is the multiplicity that tells me that it happens twice. So to find my asymptote, I only got to solve one of these since they're the same. So I'm just going to take the x minus 2 and set it equal to 0. Solve that by adding 2. And I get x equals a positive 2. So this will say the equation for the asymptote all right, so they'll write all this. The equation of the vertical asymptote is x equals blank. So on this one, they're giving you the x equals. All we got to do is put in the 2 on that, okay? All right, same thing. F of x equals x minus 5 over x squared plus 2x. So take the bottom, set it equal to 0. Since I got an x squared term, I'm looking for 2 answers on this one, just like I had 2 answers up here, but they were repeats of each other. This one, I've got an x squared term and an x term. So what I'm going to do to this one is factor out the greatest common factor of x. Notice both these have an x in them, so we're going to factor out an x. So if I had an x squared, I factor out an x, that's going to leave an x, plus if I have a 2x and I factor out an x, that's going to leave me a 2. So we're factored, set each factor equal to 0. So y'all, once again, the greatest common factor of x equals 0. Every time you factor out that variable as a greatest common factor like this, it's always going to equal 0. And then on this one, y'all, we're just going to subtract 2. And I get x equals a -2. So for this one, they actually got an A, B, C, D answer. And the one we want is x equals 0, comma, x equals -2. And they'll give you one like x equals 5, x equals -2. And then they change the signs on some of these. So if they give you A, B, C, D, you're looking for the one that looks like 2 equations with your 2 numbers in it. All right, y'all, number 5. F of x equals x minus 3 over 1 minus x. All right, so what I can do here is take the bottom. I've only got one x this time, so I'm only going to get one asymptote. So set 1 minus x equal to 0. Now, if you want to, you can subtract 1 from both sides and then divide by that negative to make that positive. But usually when I see something like this, if you just add an x to both sides, sort of like the one we had a while ago, that leaves the 1 over here, that cancels, and then that equals my x. So this one will say the vertical asymptote is at x equals blank. You know, all we got to do is put that, they're giving me the x equals already, so all I got to do is put in my 1 on that one and move on. All right, so let's do a couple more of these vertical asymptotes, and then we'll look at what we call horizontal asymptotes. And y'all, then at the end, I'll show you actually how to graph using all that stuff, okay? All righty, so this will be my number 6. So this one we have f of x equals 3 over x plus 5 and x minus 1. All righty. So this is already factored, but I still got to come and set that whole thing equal to 0. But it's already factored, so I can now set each of my 2 factors equal to 0 and solve. So we like it when MATLAB has it already factored, okay? So the first one, we're going to move that by subtracting 5. X equals a -5. Second one, I'll move to -1 by adding 1. And I get x equals 1. So y'all, let me see how they're doing the answer on that. This one also gave you 2 answers. So we're wanting the one that has x equals -5 and x equals +1. So that's another one where they gave you A, B, C, D, okay? All righty, so let me see what we got here on this number 7. So this one has f of x. Now this will be our last one for the vertical asymptotes, okay? This one has on top x squared plus 4x minus 12 over x squared minus 2x minus 8. I think a lot of this section is just getting you good at playing with these quadratics and seeing how you got to factor them, okay? So let's set this equal to 0. Now, they're not nice. They factored this one, but they didn't factor this one, so we get to do that. So y'all watch me put my signs in first. X squared in the front is an X and an X. This last sign is negative. Remember, when the last number is negative, you're going to have unlike signs no matter what in these parentheses, okay? Now, since the last number is negative, I'm going to find factors of 8. So I need factors of 8 that'll subtract and get me a 2. So y'all, what do we got? We got 1 and 8. But if you subtract that, that gives me what, 7?
4 and 2.
So there you go, 2 and 4, because if I subtract them, I get a 2. Just remember the larger number, which is the 4, has to be negative like the middle number. So the larger number always has the same sign as the middle, and then the 2 will be positive. In the way you check your signs, 2 and negative 4 equal negative 8. If you had them backwards and then negative 2 plus 4, you would get a positive 2 instead of a negative 2, okay? All right, y'all set both them equal to 0. And let's solve them by subtracting 2 on the first one and adding 4 to our second one. Now, they'll have answers with these negative numbers like negative 4, because a lot of people, once they factor it, they think they got the answers. But you got to work them out and get them signs changed. So, y'all, this was another one that did it like this. X equals negative 2, comma, X equals a positive 4. Now, be careful. Some of them, they put Y's on them. But remember, vertical lines are always X's. The horizontal lines will be the Y's later, okay? All righty, so let me see what I got. So y'all, we can do 2 things. See what y'all want to do. We can take a break now for about 10 minutes, or I'm thinking I might have about 20 or 30 minutes worth of notes left is all. So do y'all want to take a break and then finish, or do y'all want me to just finish it and be done?
Finish it and be done.
Finish it and be
Yeah,
done. Sounds
finish.
good to me. All righty, so majority rules. Here we go. So next we're going to look at horizontal asymptotes. So let me see what my chat done. So chat said finish it also. Okay. So we're looking at our horizontal asymptotes. So these are sort of similar to the vertical asymptotes, but these are going to be imaginary horizontal lines that the graph tries to approach. As the x values head towards negative infinity or positive infinity. okay? So, remember, these are imaginary horizontal lines. So let me show you sort of what would happen. So there's my X and my Y. So say my function was just 1 over X. Now we know that's going to be undefined at 0. At 0 here, you cannot cross. So let me see. So we know the vertical asymptote will be at 0 because that's the only number I could put in it that would make that thing undefined. So you would have a vertical asymptote there. But y'all, I want you to see what we're talking about when we look at a horizontal asymptote. And I'm just going to play with the right side of my graph, okay? So watch this. If X is 1, 1 divided by 1 is 1. So when X is 1, my Y is 1. So let's just say that's 1 for both lines, okay? But when I put a 2 in for the X, I get 1 divided by 2, which is 1/2. So when my X is 2, mine is coming down here to 1/2. Well, look at this. When I put a 3 in there, I get 1 divided by 3, which is 1/3. So right here at 3, it's getting even closer to the X-axis. So y'all, if I put a 4 in there, I'd be at 1/4. But what if I put 100 in here? Y'all, I will be at 1 over 100. So way out here at 100, I would be really, really close to that X-axis. And y'all, if you punch 1 divided by 100 in the calculator, you're going to get a 0.00 whatever. What if my X went out to 1,000? This would be 1 over 1,000. That's going to be 0.00000. Who knows how close? You're trying to get close to the 0, but guess what? You never will reach the 0, but you're going to get really, really close. So a horizontal asymptote just means it's cruising along at a certain value and it's trying to get closer to it, but it never will cross over it, okay? It'll just keep getting closer and closer. So in my case, it was getting closer and closer to 0. So mine would be like at 0, an imaginary line that my graph was just trying to get closer to, okay? 1,000,000, 1 divided by 1,000,000. That's really close to 0, but it's not 0, okay? So for horizontal asymptotes, you got 3 cases. In horizontal asymptotes, we look at the degree of the top and compare that to the degree of the bottom. Now, if the degree of the top is greater than the degree of the bottom, well, if the top is a higher degree than the bottom, this is the only case where there is no horizontal asymptote. Second case, if the degree of the bottom is greater than the degree of the top. Well, y'all, the one I had here had a degree 1 on the bottom, degree 0 on the top because there's not a variable. So since the bottom was higher degree than the top, look what mine did. It tried to get close and close to 0. So the graph tries to get close to 0. So that means the horizontal asymptote will be y equals 0. Anytime the bottom is bigger than the top, you're going to get a y equals 0 will be the line it tries to get to. Third case is, what if they're equal? If the degree of the top equals the degree of the bottom, then the asymptote depends on A over B, where A and B are the lead coefficients on the top and bottom. So that'd be the lead coefficient on the top. The B would be the lead coefficient on the bottom. Now remember, if you got an x squared on top, a 2x squared on the bottom, so if you had something like this, x squared on top over 2x squared on the bottom, remember A over B would be the numbers in front. So you got to remember, if there's not a number in front of that variable, you got to put a 1 there. So for this one, the asymptote would be 1/2, because that would technically be the lead coefficients on the top and the bottom. All right, so we're going to do 3 of these real quick. So for these examples, so let me get my camera back up. Now remember, horizontal asymptotes are y, verticals are the x's. So for these, we want to determine the horizontal asymptote of the graph of the function. All right, y'all, so this looks like number 8 that I'm about to do. Number 8 has f of x equals 5x to the third plus 4 over 3x to the third minus 2. So the first thing you got to do, the degree on top is the highest exponent, which is that 3. The degree of the bottom is the highest exponent on bottom, which is a 3. So for this one, the top equals the bottom. So since they were equal, my horizontal asymptote will be A over B. So y'all, I need to figure out what is A and what is B. What y'all think?
2 over 3.
Oh, what was that? I couldn't hear the very first one.
I mean 5 over 3.
Okay, you're perfect. So 5 over.
I'm doing a different I'm doing my math lab problem and
okay.
just subbing in my numbers for yours.
Uh-huh.
So I was looking at.
So they're really close other than that 5 then. So in math lab, you just put y equals 5/3. And let's see, they got the y equals. So all y'all got to do is punch in the 5/3 on that one, okay? All right, how about this one? F of x equals x squared minus 5 over 3x to the 4th plus 5. So let's see, the degree on our top is this 2. The degree on bottom is a 4. So this one has a bottom greater than the top. So y'all, when the bottom was greater than the top, what did we say about our horizontal asymptote?
Y equals 0.
Y equals 0. And let's see on that one, they got the y equals. So all you got to do is come in and put that 0. Yeah, every time that bottom's bigger, that's all you're doing, okay? All righty. Whoo, this one's a long one here, y'all. F of x equals, whoo, my top has an x to the third minus a 2x squared plus an x minus 4 all over x squared minus 18. All right, y'all, so let's see what we got on top. Ooh, my biggest exponent is the 3. On bottom, my biggest exponent is the 2. So this one has the top greater than the bottom. So what did we say about that horizontal asymptote?
There is no one.
There you go. So and they'll actually have that answer. There is no horizontal asymptote. So y'all notice you're going to get one of each one. One where you got to look at the A over B numbers in front. One where the bottom's bigger and you just put the 0. One where the top's bigger and you tell them there is none. All right, so I think I can knock out the rest of this in probably about that other 10 minutes y'all was talking about. So let's see. So this example wants me to find the domain, any asymptotes, X and Y intercepts, and then they say choose the graph. So we'll do one of these two. You'll have two, but they're both the same way. So we'll do one of these and y'all should be good to go. So y'all, this one for me has a f of x equals 3x plus 3 over x. So the first thing they want me to find is the domain. Well, remember, the domain, all I'm worried about is the bottom of that fraction. So if I look at this fraction here, there's only one number that x cannot equal, and that would be a 0. If x is 0, that makes that undefined. So now I got to do my interval notation. So we're going to start at -infinity, kick out that 0 by unioning around it, and then from 0 to infinity. All righty, then let's see. So if I was looking at a vertical asymptotes, because you'll need to know this to choose the right graph. A vertical asymptote occurs at the same point where it's undefined. So if my graph is undefined at 0, that means my horizontal asymptote will be x equals 0. At that 0, I'm going to have that imaginary dotted line. So y'all, now I'm looking at my horizontal asymptote. And the top degree is a 1, the bottom degree is a 1. So the top equals the bottom. So your horizontal asymptote will be y equals, when they were equal, we looked at the numbers in the front. So this is basically a 3 on top, a 1 on the bottom. So that'd be what, 3 over 1. So we would actually simplify that down to a 3. Okay, so remember, when they're equal, x and x, you're looking at the numbers in the front. All right, then they want us to find the x-intercept. So y'all, to find the x-intercepts, you're going to set the top equal to 0. So the top of mine is 3x plus 3. I'm going to set that equal to 0 and solve it for the x. So y'all, what are we going to do? Subtract 3. So I get 3x equals a -3. Then divide both sides by 3. So I get x equals -1. Now remember, that's the x-intercept. So that means my graph crosses the x-axis at that -1. Now, They said, hey, find me the y-intercept. All right, to find the y-intercept, I find f of 0. So remember, to find f of 0, I take my function, 3x plus 3, and put a 0 in for the x's. So I got 3 times 0 plus 3 over 0. So y'all, I can't do that, can I? Because when I put a 0 in for the x, this thing is undefined. So since this is undefined, so that means there is no y-intercept. But that makes, if there's a vertical asymptote happening at 0, well, I can't have a y-intercept because remember, my graph can't cross over that vertical asymptote, okay? All righty, so y'all, let me show you. I'm going to pull this up on a graph real quick, just to show you real quick, and then we'll pretty much be done. Now, the trick on this, I would plot these like fractions. Look, so I would always hit the alpha y equals and then enter so that it looks like a fraction. If you don't do it like this, you have to put parentheses around the numerator and denominator, okay? If you're not doing it like this. So y'all, we had a 3x, whoops. 3x plus 3 on the top. And then I'm going to arrow down and I had an x on the bottom. So let's go graph this. So you can see at the y-axis, that's where x is 0. That's going to be your vertical asymptote. And if you notice, to the left, it wants to keep going out straight. To the right, it wants to keep going out straight. But if you notice, if you go up about 3 on that y-axis, you can tell that they're both trying to get to that 3 in the long run. Now, notice my x-intercept where it crossed over here was at -1. And that's the only place my graph is crossing the x-axis is at that -1. Now, y'all, we said this was trying to get close to 3. So watch this table as I make my x's get bigger and bigger. If you would start dividing these numbers out, oh, let's see. If you do 96 divided by 31, that's pretty close to 3. That'd be like 3 point something. But notice, the further I go down these x's, if you take 168 divided by 655, that'll be like 3 point something. It's getting really close. And it'll keep getting closer and closer to that 3, but it never will equal 3, okay? 195 divided by 64. Watch this. Let's divide that. 195 divided by 64. Look, 3.04. The further I go out, the closer it's going to get. 3.00, 3.000. It's going to keep trying to get close to 3. It just never can get there. So y'all remember what my graph looked like. And then I'll show you what they'll do to them answers. So notice mine's coming down the left side down and from the top on the right. So if you notice here, mine was coming down on the left side, and then on the right side it came down, and it was trying to get to that 3 where they got that dotted line at, okay? I'm gonna zoom that in where y'all can see them better. Okay, so look at my graph and let's figure out A, B, C, or D again. And remember, we had to cross that -1 there, so let's go back and look. So y'all, looks like crossing at -1. The only one I could go with would be B. To see this D is crossing over the y-axis, and we said it couldn't do that. It was undefined right there. So it has to be B on this. So just play with those, and you're going to find whichever graph matches your calculator, okay? So y'all, they a little tricky to graph, but I just mainly want you to get good at finding these vertical asymptotes and horizontals. And then that calculator is going to graph everything for us. So y'all, if you notice, the main thing today was playing with the domain mainly. And then those vertical asymptotes, which are the same pretty much as finding the domain. So vertical asymptotes was always set in the bottom. The tricky one, you got to use those three cases that are on those horizontals. Are the degrees equal? Is the bottom bigger or is the top bigger? Okay. All right. Also, any questions? So Monday we'll finish out 8.6. It's a little bitty section, and we'll probably start reviewing for our third test. Okay. So y'all don't forget, if you haven't done my test 2 yet, it's due Sunday night. Okay. If you're going to do the bonus that I sent you on your email, it's due Sunday night. So you can either email me that or text it. All right, also, let me quit this recording.